instead of going after a shiny thing, we could have spent our time thinking, okay, what is the business problem?
Exactly.
Like, what is the simplest thing now we can solve this?
Hi, Alexey. Welcome
Hello.
to the show.
Yeah, thanks for having me.
Alexey, oops, let's do this again. Sorry. Today we have Alexey on the Data Scientist Show. Alexey is a principal data scientist at OLX Group. He is the founder of Data Talks Club with over 4,000 members. He also wrote a book called Machine Learning Bootcamp to help people learn machine learning by doing projects. Alexey, welcome to the show.
Hi, thanks for having me.
So you started your career as a software engineer. How did you get into data science?
Yeah, so indeed, my original background was databases. So this is what I studied in my bachelor studies. And then after graduating, I found a job in Java. So I did Java for a couple of years, mostly Java, a bit of Python. And then I worked at a bank. The company was really great. They would encourage us to take different courses. And one of the courses back then that was quite like it was getting a lot of attention was machine learning on Coursera by Andrew Ng. And the company actually encouraged all the people, all the employees, especially developers, to take that course. And I thought, okay, why not? I did take it. And this is when I realized that this is what I want to do for in my career, like in the future. And I started seeing how I can actually transition. So for me, it was taking more courses. And then I tried interviewing with different companies. And then they say, hey, you don't have PhD. We do. You don't. Yeah, do something about this. And then I thought, okay, like if this is what it takes, maybe I should try doing this. Because I really wanted to do that. And I didn't have even master's. So I thought, let's start with that. I found a master's in business intelligence, also databases quite related to what I was doing, but doing before, even before, like in my studies. And I did a master's. It was quite fun. So I did study machine learning during that times. I wrote a thesis. My thesis was about extracting mathematical identifiers from, like, let's say you have a Wikipedia page about some mathematical concepts or physical concepts. And let's say, like in physics, you have this concept of energy, and then there is this famous equation, E equals mc squared, right? E stands for energy, M stands for mass, C stands for speed of light, perhaps, I don't remember. My physics was quite bad. Anyway, so you have this equation. And what I wanted to do in my thesis is to extract, to understand that E stands for energy, M stands for mass, these kind of things. That was a lot of fun. And actually, for me, that was one of the end-to-end projects I did from the very beginning, like scoping the problem, understanding the problem, because my advisor would just share the an idea with me. And I would need to do all the work. Like I would need to come up with a proposal, do some research on prior art to understand what things happen there. Like basically come up with this outline, like 2-3 page document that talks what the thesis will be about. And then if my advisor, if I call the people in the at the university, in the group where I was studying, including the professor, like the proposal, then they accept it, and then I can start working on this thing. So it was like an end-to-end project where I needed to come up with an idea, understand how to measure it, what is the scientific impact, because it has to be a master thesis, and then collect the data set, clean this data set, do a lot of modeling, like do a lot of data engineering for that. Then build a model, evaluate this model, and then write like a thesis about this. And we also ended up writing a paper. So for me, that was probably the most useful thing I did in my master's. And turned out after I graduated that this was the only thing that companies cared about, like this project.
The end-to-end project.
End-to-end project, exactly. So they didn't care about like all the concepts I studied in the machine learning classes, so, like all these derivations I needed to learn how to do. Like, let's say you have this logistic regression, like how do you go from the Bernoulli formula, like like basically all these complex derivations. Like how do you go from there to this update rule in stochastic gradient descent? No one actually cared about this. They mostly cared about, well, a few companies did ask that, but most of them, like 90%, they asked about this complex project. Like in general, like usually companies are not that interested in math. As it turned out after that. And yeah, also like when I graduated, people didn't really care about PhD. So I guess I was lucky. And so I started working as a data scientist back then. Yeah, so
really cool.
yeah. So for me, it took actually, so I needed to do a master's to actually get into this. I don't think it's necessary. So the key thing for me was this end-to-end project. And I think you don't need to go get a master's to actually do that. And especially in some countries like the United States, it's quite expensive to get a master's, right? Like in Germany, where I did, it was cheap, right? It was like 300 euros per semester, like almost nothing. But in some countries, it's very expensive. So please think about this. Like maybe there are better ways of spending these 2 years and also this money than getting a master's. That's maybe my main takeaway from my transition. It was fun. I did meet a lot of people. I did make a lot of connections. Some people I'm still in touch with, and yeah, but like if you think about in terms of career, maybe these 2 years is better to spend them in the industry and maybe just do some projects and then yeah, try to start working without spending too much time on that.
Yeah. I agree. So when people ask me, should I do a master degree, I usually ask them, are you able to find opportunities to work on the end-to-end data science or machine learning project in your current work? If it's very hard for them to transition, find the opportunities, and then they happen to have the savings for a master degree, I think it's a great path to go. And then you also immerse yourself in this environment, and then you have this recruiters come to the campus, definitely make it easier. But I also have a lot of colleagues, they don't have they didn't go to grad school. They learn through their work or take some online courses, and they become great data scientists as well. So I think what you touch on about the end-to-end project is very important. And for folks who are looking to transition their career but don't know how to start building this type of end-to-end project, what's your advice for them?
Yeah, so just maybe there is something that in the domain where you work in, maybe there is something there that you can already do. So take a look around and understand what are the processes around, like do any of these processes generate data? Can you use this data somehow? Even simple things like, let's say you want to search for a flat. So you want to rent a flat and you want to look for a new one, right? So then perhaps you can build a scraper that scrapes some website where you look for this kind of listings. And then, so build a simple pipeline and then collect the data, do some simple analytics to understand, okay, what are the districts that are more expensive, what are the districts that are less expensive? So play with the data, try to understand it. And yeah, then once you have that, you can also build a model. So for example, just for fun to understand what makes the final price. So what are the features, what are the factors? And then, yeah, just think of things you do right now that are important for you, and then you can try to see what can you get some inspiration and build that. And I think it's important to also think about like how you do this end to end, how you also collect data. It's not like you just take a CSV file that somebody built for you and you import scikit-learn and apply a model for that. That's also important, but also think a few steps before that and a few steps after that. Like how do you build a model? How do you deploy it? Like it would be fun, for example, to build a website where, let's say, if we take the example of building a model for predicting the rent, where you would just maybe build a website and put an address, and then it would say how much money a flat in this address should cost, for example. Like, it could be quite fun to do this end-to-end thing. Yeah. And also, like, I know it's sometimes difficult to come up with such ideas. You can try also to find some projects. Maybe people are looking for, like, they have their own project and they look for contributors. You can also work with them, or just go on to Kaggle, download that CSV file that somebody prepared for you and do some analysis there. Like, it's also okay. Like, you don't have to stress about being end-to-end too much. It's useful, it's important, but you got to start with something. And you can just start with working with a CSV file that somebody prepared for you. That's also fine. Just be sure at some point to include an end-to-end thing in your portfolio as well.
Yeah. So if someone has a end-to-end project on their resume, when you interview them, is this a plus for them?
Yeah, definitely. It's more also, it's like, let's say somebody doesn't have experience. I was interviewing interns a few months ago. So let's say I ask, have you done any projects? And then if they say yes, like there was this course project or there was this pet project, now we have a topic to talk about, right? So now I can ask things like, hey, why did you do this? Why did you do that? And then, yeah, there is material to talk about, and I can understand what kind of decisions they needed to do, why, like, basically understand the project, the person better. But if they say, no, we don't have a project, then what should I ask? Well, I can ask, well, what did you study in your machine learning class? Like, okay, let's talk about linear regression. What does it do? But like, it's boring. And then like, then it's like, even conversation is more difficult.
Yeah.
So it just helps a lot to talk. And then talking about my experience in transitioning. After I graduated, so I had this interview at a company, and most of the time we spent talking about my thesis. So there was a topic that was interesting to the people who interviewed me. This was something I was comfortable talking about because this is something I did end to end. And we spent, like, I think it was quite long, like 2 hours. We spent a lot of time talking about my project. And yeah, it was a lot of, like, it was a great interview. It went really well. And both of us, also, I think the person who was interviewing me, also the team was there. And me, like, we enjoyed the process. That's why I think they made an offer.
Yeah. Even if I remember you mentioned the end-to-end project was more of extracting some data, some factors for the physics formula. What I learned is sometimes the end-to-end project, the data science related project, doesn't have to be exactly the same as what the team is hiring for. What they're looking for is your experience to formulate a business problem into a data science problem, work on a project from the beginning, finding the data to all the way in the end to evaluate a model, implement the solution. So a lot of people, when they look for this type of project, they try to find very fancy projects, maybe some deep learning project, but for companies who are hiring, especially I would say entry-level engineer or scientist, it doesn't really matter, right? It could be a linear regression, logistic regression, but you solve a very interesting problem. That's very important project for you. So what I suggest for people is don't think about what model you use. Find a project that interests you. When you're interested, you're more motivated to solve it because you're going to encounter a lot of obstacles along the way.
Yeah, exactly. And if you're passionate about this project, if you're motivated, this is like, if you're solving a problem that occurs in your life right now, then you are more motivated than because like this thing with with projects sometimes, and in general in programming, sometimes things don't work and you have no idea why. And then you need to spend a lot of time trying to debug the thing, trying to figure out, just to find this, there's maybe an extra comma somewhere, or like silly stuff like that, that takes a few days to figure out. Like, you need to have energy to, go through this process, to, to have motivation to finish your project. And if you care about this project, chances that you will finish are higher.
Yeah. And then you also mentioned when you, in your previous job, you started your machine learning journey by taking Coursera courses. So now working in the industry for a few years as a principal data scientist, what is something that you can only learn by working in the industry that you didn't learn from online courses? What is something you wish more data science practitioner would know?
So at university, there is a lot of emphasis on mathematics, like how to derive certain things. And I remember this lecture about SVM, where there is a lot of math, a lot of complex math. You need to know like all this convex optimization. You have this slack variables, KKT conditions, like all these different things. And it seems like when I am there in this lecture, watching professor explaining this, it seems like the most important thing on earth. Like if you really want to get into machine learning, you really need to understand all that. But now I'm sitting in the office doing machine learning, practical machine learning, and nobody actually cares. Well, first of all, nobody, like very few people still use SVMs. I don't know. I don't remember last time I used an SVM. And the second thing is like, it's not maybe important how a certain algorithm works inside, but the important thing is how do you translate a business problem into something that you can solve with machine learning? I don't think universities teach that, and I don't know if it's actually possible to teach at university that. So maybe this is one of the things where you really need to work. And also another thing, I think that the university, at least for me, it was the case, didn't emphasize was the importance of cross-validation, like setting up this validation framework. Because again, all the focus, at least it seemed to me, was on mathematics. But what is important in my work is being able to test hypotheses quickly. Okay, this model works better. Like if I add this feature, maybe it will improve. The only way to know this is to test it, right? And to test it, you need to have a framework for doing this, for validating your ideas. And so you typically do it with cross-validation. So you hold out a data set for a part of data set for testing, you know, that thing. And I think this is not emphasized enough at university, that in my opinion, knowing how to set up this validation framework is one of the most important things in applied machine learning. And this is something you can actually pick up in Kaggle, like in Kaggle competitions, because if you want to really do well, like with modeling, you need to have to set up this validation framework, because otherwise you would need to submit like all your solutions to the leaderboard, and you would overfit to leaderboard. I don't know how many people know about Kaggle. This is like a platform for data science competitions. But yeah, so this is where I learned this skill in Kaggle, and that was very useful at my work. So knowing how to do this. And actually, this is one of the things I ask quite often in the interviews to make sure that people really get it. Because I think this is like one of the fundamental things is knowing how to validate your models.
Yeah. So can you elaborate more on that? Because you talk about it's just cross-validation. If you want to test the hypothesis for multiple models, how do you do cross-validation? Do you keep do you split the data within the same set, or every type of model you do a different type of split, or do you have a different strategy for the final test set that you hold out?
Well, usually a good idea if there is some time component in your data. So just take most recent data and hold it out. So put it away, don't touch it at all. And use this for testing only. And testing means like, so let's say for now, we just put it away. And now we want to find what is the best model. So we take the remaining data set, and what we can do there, like many things, many different things. Maybe we can just use the usual k-fold cross-validation, like let's say, split it into, let's say if we are talking about 3-fold cross-validation, we take our data set, split it into 3 parts, we train a model on 2 parts and validate it on the 3rd part. And then we repeat it for different chunks. And then we have 3 scores. So we trained the model on 3 different parts. and then evaluate it on, like, I guess it's very difficult to explain it without a visual.
Yeah.
But yeah, so this is like a typical k-fold cross-validation. If you just Google it, you'll find a lot of resources that also have the code that show you how to do this. And maybe if you don't know what this is, maybe if you go there and read it, maybe what I'm saying will make more sense. So you do that. And yeah, often that is sufficient just to do this. Of course, sometimes there is a time component is very crucial. And yeah. So what I should have mentioned is you do this, and you do this for many models. So let's say you have logistic regression, you have, I don't know, random decision tree, random forest, XGBoost, like all these different models. And you have to make sure that the way you test logistic regression and the way you test the decision tree, the way you test the random forest is exactly the same. So the split you have, so let's say you split your data, like the remaining data set, into 3 parts. This split has to be the same for every model you test on. Otherwise, you will not be comparing apples to apples. Right. So if you test one model on one data set, the other model on another part of the data set, yeah, you don't know if you're comparing the same thing, because maybe there is one particular record where all the models are bad, right? And one model got lucky because it didn't see this record, but the other saw it, and that's why the score is worse. So basically, you need to make sure that the data sets, the splits for all the models are the same. So you do that, you select the best model, and then you come back to this data set that we held out, and you evaluate. Only then, when you say, okay, this model is the best one, only then you go and check it against the test data set. So this is like
you need to make sure you compare apple to apple.
Yeah, exactly. Yeah. And then there are more complex cases, like when there is this clear time component, then the way you do cross-validation might be different, because the way I described previously was you can just shuffle data and randomly select, like split the data into 3 groups. But sometimes what you need to do is, let's say you take data for 2 months, you train a model, and you evaluate it on the next month, and then you kind of slide it. Then you take the next 2 months and then evaluate it on the next one. And you do this for, I don't know how much data you have. Maybe it's for 10 months. And this is how you do this to make sure that your model, when you deploy it to production, will actually be able to act on new data. Because this is a typical situation that you have. So you train on historical data and you apply to something new. And the best way to model the situation is to make sure that your test data set is sort of coming from the future for the model. It hasn't seen it. It hasn't seen any data from that time. So this is like one of the simplest way to make sure that your model indeed can generalize to new unseen data. Yeah.
So if people want to learn more about this, do you have any courses? I saw that you started a Zoom camp. Are you going to teach more practical machine learning techniques in your Zoom camp?
Exactly. So Zoom camp, I don't know, maybe if I can say a few words about my book. So because the Zoom camp is actually based on the book. So the book is called Machine Learning Bootcamp. And this is an idea coming from the publisher's marketing department. So this is an ingenious idea, although it makes it a bit difficult to Google, actually. Like if I Google Machine Learning Bootcamp, it says, did you mean Machine Learning Bootcamp? No, I didn't actually meant Bootcamp. Anyways, so the book is actually for people like me, for people who who want to transition from being a software engineer, software developer, to data scientist, basically for coders. You don't have to be a software engineer. Maybe you're a student, but you like coding. So this is the kind of target audience for the book. Although data analysts also told me that they like it. And I teach machine learning through projects. So let's say there is a second project when we predict price of a car. So we basically go through like, okay, there is this data set. We do exploratory data analysis. We find out that we need to do some pre-processing of the data, and then we implement the linear regression. Then we try to add new features with also measure this, and So basically, instead of the way I studied machine learning was, hey, there is this formula, let's derive it. And then at the end, maybe there is an exercise where there is some generated data where you need to apply your model and then, I don't know, report some coefficients or something like this. So here I'm taking different approaches. So first, you have like a data set, and let's go through this data set together. Yeah, so the idea, so there is this book. And of course, I talk about cross-validation there in one of the chapters. So there's a chapter about evaluating machine learning models. So I have this book, and I thought it would be cool to actually do a course about this book, about the content of this book. So actually, the course is free. And this course, I thought, since it's remote and the book has this kind of funny name, machine learning Bootcamp. So I thought, how about naming it a Zoom camp? Yeah, so basically the course will be the same content as the book plus homework. We will talk about things like I just mentioned, like predicting the price of a car, building a churn prediction model, then also evaluating the quality of these models. We will definitely talk about cross-validation because as I said, this is one of the most important things in machine learning. So I think it's more important to know how to do cross-validation than know how to, let's say, random forest works.
Yeah.
Because if you have this validation framework, then you maybe don't care how a random forest works, because you know that for this data set, it shows this particular performance, right? And that this is, for some projects, this is good enough. Like if you want to focus on business impact rather than, mathematics.
Yeah. And previously, you mentioned another thing you wish more people would learn is how do you translate a business problem to a data science problem? And this is also important during interviews because we have machine learning case studies. Usually it's an open discussion question. A lot of times, even the people interview you might not have a great answer. They want to see how you think, how do you approach this problem? So do you have any advice on how can people practice machine learning problem solving or the business problem translation?
I mean, one thing is at work, but I guess this question, so people who already work and who already in data science, maybe they will not ask this question because they know, okay, I just work, I just look at how my colleagues work and see like what they do, and basically learn from that. For people who do not yet work, there is still a way to pick up some of this. Maybe it's not ideal, but still I think you will you can learn something on your own even without working. And this thing that I'm going to suggest will be useful for those who also work right now as data scientists. Like even if you're a senior data scientist, it will be very useful. The trick is to use Kaggle. And many people say, hey, but Kaggle doesn't teach you that. Kaggle only teaches you how to take a clean data set, train a model, train millions of models, put them together and, overfit the leaderboard. Yes, Kaggle does teach that, but that's not the only thing. Because if you look at a competition, so first of all, the company who runs the competition, they needed to do a lot of preparation work. So they needed to think, okay, what is an important business problem that we want to solve now? So we want to ask the community to help us solve this problem, right? So a company has a clear problem, right? Let's say I took part in a duplicate detection contest. So it was a company based in Russia, Avito. Avito is an online marketplace where people sell things. And some people, let's say the same person can post the same listing twice, right? So they're selling an iPhone. So they put one listing of an iPhone. The next day, they again put another listing of the same iPhone. So this is a duplicate. So the company had this problem and they decided to run a competition to ask the community, hey, can you help us build a model for this kind of problem? So they went, first they understood that this is a problem that is important for them, right? So then they collected a data set and then they defined a metric. They defined, okay, how now we can actually evaluate different people, different solutions and see who is the best one. So they came up with a metric and they did all this hard work and you can actually learn from this hard work. So you can take a part in the competition. You don't need to spend a lot of time. So what you can do is first try to understand what is the problem that they are solving. So in this case, the problem was duplicates, right? And I think you can relate to this problem, right? If you ever used any online classifieds website, maybe you saw duplicates, and then you can immediately understand what they want to solve, right?
Yeah.
Then you can look at the data set that they prepared. You can see what kind of features are there, what kind of data is available in general. And then, so you have that. So you already know the problem. You know what kind of data is available to solve this problem. And then you can also look at the metric. So for example, in this case, they decided to model this as a binary classification. The metric was AUC, area under the job curve. Yeah, so you can also see that, okay, for this type of problem, you can use this metric to evaluate models. And then not only that, like even if you don't take part in the competition, you can just look in the forums. Like in the forums, people say, this is what we tried, this is what worked, this is what doesn't. And especially if competition already finished, there is like at the end a solution sharing thread where people say, okay, like this is the solution for, I don't know, 10th place, or this is the solution for 5th place. And usually they give like a pretty short description of the features they used, of the feature engineering techniques, of the models they used. Like even if at the end, if they do a lot of stacking, like always ensembling, there's still a lot of useful information in this post. So you can just, you know what the problem is, you know what the data is, you can just go there and read the solution and maybe have some sort of a document where you do this. And then you put this for this competition, and then you take another competition and do the same thing. So you try to understand what the problem is, you try to understand what the data is, and you try to understand what the solution is. And you do it for the next one. And then you can do it for 10, 15, 20 projects, and then you will see a pattern. Okay, like maybe for click prediction problems, when we want to predict, like, I don't know, the likelihood of somebody clicking on an ad, this kind of data is usually available. And this kind of techniques usually work. So for example, for this kind of competitions like click prediction, simple linear models usually work better than, let's say, tree-based models. Then this is something you can learn by just looking at by just following this approach. Yeah. And then if you do this for 20 projects, you will have like I don't know, a document with 1 page for each document, for each project. And this is how you can learn this. And then on an interview, if somebody asks, hey, how can we implement a click prediction system? And then you can say, okay, yeah, like this is the kind of data we can collect. Maybe you will miss some important business metrics, right? Because in Kaggle, we usually don't talk about business metrics. We talk about, you know, how we evaluate our models. We talk about accuracy or AUC or log loss or whatever. So that part will be missing. So that part you will have to pick at work. Yeah. I don't know a better way, but a large chunk of work, like you can learn a lot basically from doing this. And I definitely recommend you spend like maybe a week just doing this. And then like, I am pretty sure that for your interviews, it will be very helpful because you will learn a lot from this and you will be able to use that in your interviews.
Yeah, that's a great advice. And you also mentioned business value a few times, and business value can be the time you save for your team or the money you help your company make more, or automated some reports that reduce some human labor. So when you build a machine learning model, how do you decide whether the model performance, for example, accuracy, precision, and recall is good enough to meet the business value?
Well, usually even before we start the project, we sit with the stakeholders. So these are usually the people from business who came up with a problem, saying, hey, we have this problem. It seems like it can be solved with machine learning. So we have like a long discussion with them. And one of the things we try to figure out is what is an acceptable level of quality, or understand what is the current status quo, like what is the current benchmark on this problem, like how this problem is solved now. And then we can see, okay, like we want to have, like, even if the stakeholders tell you, like, even if we have like, I don't know, 5-10% improvement over the current baseline, current benchmark, this is good. And this is what you aim for. So basically, it all depends on a particular use case, like on a particular case. And this is something you usually agree in advance to know how much you need to, like how accurate your model should be. And oftentimes, like this, maybe there is some benchmark. Let's say if we take a case I worked on recently. So I work at OLX Group. OLX Group is also online classifieds, like Avito I talked about previously. So at OLX, people sell things. So if you want to sell an iPhone, you go and you basically create a listing. So what happens is sometimes people create a listing, they sell an item, but they don't deactivate it. So the item stays there on the website. People come to the website, they want to buy an iPhone. They write the seller, say, hey, is this available? Because it seems like it is, but the item is already gone, right? So like it was already sold, but it still stays on the platform. So we thought, okay, like maybe there is something we can do with machine learning to solve this problem. And one of the simple benchmarks there, baselines, was that if there was at least one conversation between a buyer and a seller, then it's more likely that this item was already sold, right? So if there was a conversation between them, like buyer wrote something, seller replied, and then buyer wrote something again, then this is a good indication that this item is gone. So you don't need any machine learning here, right? So this is simple analytics. So this is a benchmark that you use for comparing your future models with like the current status. If it turns out that your model gives you only like, I don't know, a small improvement over the current baseline, then maybe you don't need to spend all this time deploying the model. But if it's a good improvement, like, I don't know, 20%, 30%, then it is like you should, like it's a good. And then how good is good, you need to discuss with the stakeholders.
Yeah,
like with
exactly.
the business.
Yeah, there's no universal benchmark on how good is good. And it's always important, like you mentioned, to have a benchmark to know how the problem is solved today. Otherwise, if the benchmark is already 90% accuracy, has 90%, has had a high percentage accuracy, then that means your model have to be better than that. So a lot of times, I think new data scientists just directly dive into the problems without understanding what is going on today and what is the benchmark you need to compare and make the business decision. So I think this is a very important point.
And this is not something that we learn at university. And it's also difficult to learn at Kaggle, right?
Yeah.
So like it requires a lot of communication with business owners, stakeholders, like people who are interested in this solution. Often it's product managers, for example. So you cannot learn these things. You can only learn them by doing this, by practicing.
Right. So for this type of learnings, what are some common mistakes you see new data scientists made, and what type of advice you would give them?
Probably we just talked about one right now, right? That jump in with a solution immediately, like, hey, we'll just train XGBoost because like it works really well on Kaggle, so let's just throw all the data in XGBoost, and then we see that the model is like I don't know, super accurate, but it requires a lot of features, and now you need to implement all these features. You spent a few months implementing like all these pipelines to get the features. But then it turns out that actually the baseline was okay. Right?
Yeah.
And like you spent a couple of months working on something complex that was just slightly better than like a heuristic. And then like, okay, why did you do this? Like, why did you spend this time? Also, another thing is like I also experienced myself is trying to run after new shiny things. So for example, one case was that I remember a few companies ago. So we bought a computer, like a computer with a few GPUs. It was super exciting. Like, hey, now I can, like it was something new, like 1080 NVIDIA, two of them actually in one computer. And we thought, okay, how cool, now we can like solve all our problems with new neural nets with deep learning. And then there was a problem about generating titles. So basically, So the company was doing search engine optimization. So we were helping copywriters write better content. And yeah, so we thought, okay, how cool, we can just generate cool titles with machine learning. And we spent a lot of time just figuring out how to do this. And yeah, the titles were funny, but not something we would put in production. And then at the end, what worked was a simple template, like just creating some templates and trying to figure out how to actually fill these templates with super simple things. Like it was not even machine learning, it was just a bunch of if statements. Yeah, so like we learned that the hard way. So we spent a lot of time. To be honest, we also had a lot of fun because it was fun to try all these things. So it was also fun in a sense to see like what kind of titles the model suggests. Like all of them were like stupid, silly, like they had some relevance to the article, but most of the time there was some nonsense. So that was fun playing with these models and NLP models. But yeah, this is not something you put in the product, and like frankly, we just wasted a couple of months of companies' time, right?
Yeah.
Like instead of going after a shiny thing, we could have spent our time thinking, okay, what is the business problem?
Exactly.
Like what is the simplest thing now we can solve this? And maybe we would immediately arrive at the solution we had at the end, like with these templates. Of course, we would not have been able to play with all this cool stuff, and these 2 GPUs would stay idle. But yeah, maybe we would have made some impact on business.
Yeah, I'm so glad you brought up this example, because machine learning doesn't have to be the solution for everything. Sometimes if a rule-based algorithm solve the problem, like what you mentioned, we're not using it. Our goal is to, again, solve the business problem instead of, play with the most, the newest or the coolest tool. It's always great to keep up with what's going on with the newest research, so you're aware of all your options. But when in reality, there's no, it's not like the cooler model you're using, the better results you're going to get for the business. So I think this is a very important part. So we talk a lot about, your career and your advice. I'm curious, what do you do when you're not working on machine learning?
You mean at work or in general?
Or in general?
Well, I have a family, so I have a 5-year-old son.
Mm-hmm.
So I spent all my free time with him because, I don't have free time, basically. So all my time is like when I'm at home. So it's his time. So yeah, and also like I also have a side project with Data Talks Club, which you mentioned at the beginning. So I also, like when he's asleep, I also get to spend some time working on that, preparing for some interviews that I have, and also like before he comes from kindergarten, I have some time before that where I interview people. So yeah, so I don't have a lot of things apart from work, apart from like spending time with my family and this Data Talks Club.
Nice. Do you plan to teach your son some math and machine learning, other children's book about it?
I tried actually. So we recently bought a robot. So this robot, like you can, like it's basically like a rover, like a car that we can assemble. So he really liked the part when we put the thing together, and it comes with an app, and in the app you can actually program the thing. So you can just, it's like a visual language where you visually say, okay, you need to go forward, or like turn left, turn right, or blink with a red light or something like this, and then or do this sound. So you can program all that. You have a loop there, like you can repeat a thing for 10 times. So I wrote a program there that would, move the robot in some direction. And he was not impressed at all. Like, okay, like, why do you show me that? So maybe he's not just interested in that at all. I don't know. So yeah, I guess when he grows up, he'll decide if he knows, if he wants math or not.
Yeah.
So, yeah, I tried my best.
Yeah.
Well, at least I have a toy for myself now. This robot.
Maybe it's more of a toy you get for yourself.
Yeah, exactly. But it was fun.
Yeah. And for the Data Talk Club you're working on when your son is sleeping, what's your motivation to start this data science community?
Oh, yeah. So for me, actually, community was a very big part of my career, like it contributed to my career a lot. Like even if when I was at high school, so when I just got my first computer, I didn't even have access to the internet. And there was this thing called Delphi. I don't know if you know that. This is like a programming language from like it's sort of like Pascal. But yeah, so there was this tool, and I really like playing with this, trying to build something. I didn't have internet, and it was very difficult to find any information about that. So, and what I did is in my mother's at my mother's work, so she had access to internet. And then I would go to her work, and I would try to find things. And so for me, like English is not my first language, especially when I was at school, so I couldn't really find things in English. And Russian is my first language, my native language, and there was nothing like in Russian. Very few resources online. And so what I ended up doing was asking things in forums, like online communities, basically. And people answer. So like, okay, I have this problem, how do I solve it? And then somebody with more experience would come and say, this is how you do this. And it was so great. So it really helped me to understand how to solve some problems. And then at some point, I remember I wanted to also, like I went there to my mother's work. I wanted to ask something, and then I saw a question. And then I realized that I can answer that question. And then I wrote an answer. And that person, like he was, like it was a guy who was, I don't know, 30 years old, already a professional working with this thing. And that person said, okay, thank you. Like you helped me, me like somebody like from school.
Yeah.
That was such an amazing feeling, like of helping somebody. So, and then it just from there, like when I graduated from my bachelor, so I got into Java. I didn't know Java that well. I just stuck around, like I was sticking around communities. Like there were two communities in the Russian internet space back then, where people would talk about Java. So I would stick around there and answer questions. And this is how I actually learned Java. I just saw what people ask about. I would try to find an answer to this question, and I would write an answer. And this is how I learned how to actually do Java. And that was also helpful in interviews because, yeah, like all of a sudden, most of these things were coming from interviews. And yeah, I knew how to answer them because I already answered them in forums. And so for me, community was also the same thing actually happened with data science. When I started to go into data science, I found an online community about data science. So for me, that was like communities was always important for me, like for career as well. Yeah, at some point, like a couple of like more than a year ago, I think 1 year ago, like I was posting things on LinkedIn quite often, maybe like as often as you do now, like every day. I don't post every day now because I don't have that a lot like that much information to share because probably I shared everything I knew 1 year ago. But anyways, I was receiving a lot of questions on LinkedIn.
Yeah.
And most of these questions were very similar. Like how do I do this? And many of them were about career. I also talked to a couple of people, like I would have a Zoom call with them and talk about some problems they had. But that thing, like it didn't really scale. Like I couldn't, and all these questions I was getting was what, like, okay, I'm a software engineer. I want to transition to data science, or like now I work as a, I don't know, product manager. I want to do analytics, things like this. So I thought, okay, maybe there could be a place where instead of, just answering questions on LinkedIn one-on-one, maybe this is like there is a way where I can scale myself.
Yeah.
And then I remembered about all these communities that I was part in, but all these communities were actually Russian speaking communities. And I thought it would be cool to have something like this, but in English. And yeah, one day I just woke up. It was quite spontaneous. I went to GoDaddy, which is like a website where if you want to buy a domain name, so there's also Namecheap, GoDaddy, there are many of them. So I went to GoDaddy, and then I bought this Datadogs.club. So it was very spontaneous. And then I registered a Slack workplace on the same day. And then I also put a landing page on Mailchimp, on that day or the next day. I don't remember.
Yeah.
And that was it. This is how it started. So I would put just my link, this link to my LinkedIn. I didn't even announce it. I also had I also have a GitHub repository with interview questions. I put it there, and people started registering there. So it was an amazing feeling that people would just discover this thing themselves without me, advertising it. So it seemed like this thing was getting traction. And then at some point I did announce this. I put this in my LinkedIn as the founder. And then, when you put a new kind of job in your LinkedIn, it basically notifies all the connections you have. Like they have you probably saw this.
Yeah, they can see it. Yeah.
When somebody, let's say, changes a job or has a new place, and basically all the connections know, because it sends a notification. So when I did this, and I had maybe 10K connections back then, so people saw this and okay, what is that? And yeah,
nice.
Even more people got interested in this, and then it was quite fun. And then at some point we had a friend of mine asked me, hey, do you know a place where I can give a talk? And I thought, wait a minute, I actually do. You can come to us and give a talk. So it started first as a Slack group that was just growing by itself. And then, I did an announcement on LinkedIn, maybe a couple of hundred people joined, and then maybe 100, I don't remember. And then this guy asked if for a place where he could do a talk. So that was the very first talk we had in Data Talks Lab. It was about deploying machine learning models with SageMaker. Yeah, it was quite popular. Maybe 70 people showed up on that event. It was nice. Yeah, it was I got really excited, and I thought, okay, this people really care about this. I probably should continue. I should keep doing. Yeah. And this is how it started. And it started in September. So the first event we had in November. And since then, now we actually have two types of events. So we have this kind of webinars with slides, and we have them on Tuesdays, and on Fridays we have conversations like we have right now. So more interviews, podcast style. Oh, wow. Yeah, it's cool.
That sounds like a lot of work. So what are the biggest learning you had by building a community from scratch, from building a community?
Well, it is a lot of work. So what I learned is you should automate everything that is possible. So I do automate a lot of things. So I have a lot of small scripts in Python that help me with that. So for example, like when I create a new event, then there is a simple script that helps me to put this on the website. So for the website, I use Jekyll. This is just like a way to host your website for free on GitHub. So you don't have to pay for hosting. You just need to pay for your domain name. It's free, basically. But you need to spend some time putting things manually there. It's annoying. So I did write some sort of content management system, very simple one. And so now I can create a new event fairly easily. Yeah. Nice. Then also, so these scripts, then also I use things like Zapier. Zapier is like an integration tool. So for example, when I create an event on Eventbrite, this is a platform for announcing events. We also use Meetup, this is another platform for meetups, right? And what happens is when I create an event on Eventbrite, it automatically creates an event in Meetup. It automatically posts a message in Twitter. It automatically posts a message in LinkedIn. Yeah. It automatically posts a message in Slack. So previously, I was doing all these things myself, but now I can rely on this integration tool and basically get the time, right, to do some other things. Yeah. Because this is like a lot of manual work, and now the machines do this work, not me. So that was awesome. Maybe one of the learnings that I need to automate stuff, because otherwise I was spending just too much time on this.
Yeah. And then you also have a full-time job, you have family. Yeah, exactly. So when you say spend a lot of time on all those things, and especially at work, sometimes maybe some projects are stuck, or maybe your son is not happy. So how do you handle those type of stress in life?
Well, being optimistic, I guess. I don't know. I'm not sure I have an answer to that.
Yeah.
But, yeah.
Are you always optimistic when you're a kid? Is it just in your personality?
Yeah, I don't know. Like I didn't try to analyze this.
Yeah.
Just try to, keep a positive outlook on
Mhm.
things. Yeah, sometimes, like for example, I give myself freedom to cancel an event. Like when I don't feel well, I say, sorry, yeah, I don't feel well. I know that 100 people registered for this event, but yeah, my health is more important than,
Yeah.
that's why I give myself a freedom to
Mhm.
not cancel, but to schedule this.
Right.
And I try not to stress about these things. So probably that helps as well. So, and I just know that people will understand me, right?
Yeah,
that,
that's important actually,
everyone
because
is human, right?
yeah, when you prioritize your health, that means in your community or other type of work is more sustainable because you rest and then you can keep doing that. But if you keep pushing yourself to the limit, you burn out. Maybe one day you're like, why am I doing this? I'm gonna quit. Yeah.
And yeah, for example, in June I had a vacation, in July, sorry, and I just allowed myself not do anything during that vacation. So there were no events, only things that don't require a lot of attention from me. And so we have some activities in Slack. For example, there is this book of the week activity where we invite book authors to answer questions. So that doesn't require a lot of time from me. So what I need to do is make an announcement on Monday, and then select the winners on Friday, basically. So I can do these things even on vacation, so that is fine. But for example, things that require, doing an interview or hosting an event, and just cancel that because I needed time, free time of work, of community work, of everything, just spending time with family, enjoying. Like we went to the north of Germany, like the weather, like it's really great. Like there is seaside, there are forests, fields, like a lot of nature. That was really great, and yeah. So I guess doing that also helps.
Yeah, and I think especially during work from home, taking care of our mental health is very important. So going back to talking about data science and career, what do you think the future of machine learning will look like?
So I think it will be commoditized. So people now understand that it's a useful thing, but the barrier to start doing this is still quite high. So like previously people thought that PhD is important, maybe because there were no such good libraries like we have now. So people would need to implement things from scratch. So now we have all these cool libraries. We have like scikit-learn, we have TensorFlow, we have PyTorch. So maybe now you don't need to have to know in details how machine learning works. You can just use these libraries. But now it turns out that you need to be a good engineer to actually put all these things together, because you have scikit-learn, you need to calculate features, you need to somehow make this data pipeline that put the features into your model, and then you need to train the model, you need to somehow host the model, deploy the model. Like all these things is engineering work, right? So you need to write a lot of code, you need to do a lot of engineering. And yeah, I think, so I see now a trend where these things become simpler. So there are even platforms where you almost don't need to write any code. You just go there and sort of drag and drop things. They're quite inflexible, I would say.
Yeah.
So like still nowadays, I think you still need to do a lot of engineering to make a successful project.
Yeah.
But I hope to see that in the future, people like this tool will evolve. So there are a lot of MLOps tools that help you deploy things easier. Yeah, so I hope that in the future, this will become, I think, where you can just, maybe a product manager, they would just do machine learning 101, like, I don't know, machine learning for product managers, that explain them the core concepts, that explain them how to evaluate models, how to translate business requirements into machine learning terms. And then they would just go on this platform and try to connect these to some available data sources, and then maybe it will do data cleaning, all that automatically, and then people will actually be able to focus on impact immediately. So I hope to see this in the future. Yeah, let's see how it goes, because I think now like the biggest problem for people entering the field is this engineering. So now companies realize that mathematics is not the most important thing in the world, but being able to connect many different libraries together, put some duct tape around it, and put this in production. Turns out that this is quite important right now, and it makes the entering the field a lot more difficult. So I hope to see that this amount of knowledge you need, amount of engineering skills you need to enter the field, I hope to see that it lowers. But the good news is that if you're a software engineer, now it's quite easy for you to enter the field. So now, because maybe in the future when like everything is automated, then maybe these engineering skills that you have will not be as needed as now. So now if you're a software engineer and if you want to transition to machine learning, so now it's a really good time for that.
Yeah. And for people who want to have an edge in the future as data scientist or machine learning engineer, what are some skills you think they should adopt?
Yeah, well, I think now, like big data engineering, I think quite important. People realize that this is an important thing. So try to learn that as well. So in addition to machine learning, so machine learning, like of course you'll need to know the basics. And for picking the basics, you can take, for example, the book we mentioned, the book I wrote. There are other books, like you can also go on Coursera, take some classes there. So you will cover machine learning with that. But maybe try to go one step before that and think about data engineering, because many data scientists, they don't know much about data engineering because data is just appearing in a table for them because somebody took care of that.
Yeah.
And let's say if you're in a startup, who is going to prepare the data for you? Like if you're lucky, maybe there is like a software engineer has some time and can help you, but it's luxury at a startup.
Yeah.
Right? So sometimes you may end up doing this thing yourself, and it's actually a good thing. So this is how I learned data engineering, because in my previous company where I worked, it was a startup and the engineers were busy doing other things, and we needed to actually, deliver stuff. So we were a machine learning team. So we needed to show the results, and I ended up doing a lot of data engineering work, building ETLs, and like making it sort of platform-like, being able to get the data, build the model fast. That is, like to me, it was fun. Not everyone enjoys this, but maybe one advice I can give if you want to have more chances to be employable right now, and maybe not just high chances of being employed, but also being able to choose from more options or get a better salary, then I think data engineering is a good thing. But we also shouldn't forget about this thing we talked in the beginning about this importance of business skills, right? About like being able to translate a business problem to machine learning terms. So I think you should also put some effort into acquiring these skills, like especially like if you're already working, like let's say if you're junior or middle level data scientist, just look at the people who are senior already, try to mimic what they do. Try to understand why they make some decisions. Ask them, hey, why do you think we should do it this way? Try to learn from them. And by just doing this, by looking at them, you can also learn like all these things, because this is what seniors usually do. This is what product managers do, and try to be around them and learn from them as much as possible.
Yeah, that's very important to ask why, and not just work in silo, not just work with data science, but also make friends with engineers, product managers, or other business stakeholders. So yeah, that's great advice. And before we wrap up, what are something exciting in your career or in your life that you would like to share with us?
Well, I don't know. Well, I guess this thing, Data Talks Club that we talked about, I am pretty excited about this. So I saw that in less than 1 year, so now it's actually 4,500 people joined the community. This is exciting. This is what excited me. So like I'm really happy to see that people actually care about these things. So people join communities like this. People see that it's important. And when I host an event and people write me, hey, this was an amazing event, I learned so many things, I get excited. So I'm really like, I'm happy to receive these messages when people say that this was very helpful. And then it gives me motivation to actually to schedule the next and next and next meetings. So that keeps me excited. Yeah. So, and at work, like I also right now we are doing a lot of like we're figuring out what is the best way to productionize machine learning. So we've been doing this for a couple of years already, and then being able to shape how we do this. I think this is also pretty exciting. So like not just one team. So I'm as a principal, I actually not overlook, but I work with many different teams.
Yeah.
And then I'm trying to somehow have a way where everyone is doing projects in a similar way, so we can exchange knowledge, we can deploy things faster, we can put things in production faster. And I see that it's working, it's evolving, it's developing, and this keeps me excited as well.
Yeah, that's awesome. And for people who want to follow you or get updates from you, where can they find you on the internet?
Well, one of the things, like join Data Talks Club. So I'm there, you can ask a question there. So that is probably the best way to get in touch with me. Then I'm also on Twitter. My handle on Twitter is pretty awful because I registered like last year when all the good handles were gone. So my you can just Google my name, my first name, last name, and Twitter. You will find it. And you can also follow me on LinkedIn. Yeah, I'm also there. So there, it's just put on Google my first name, last name, LinkedIn, and you'll find it.
Yeah, cool. This is a great conversation. You gave us a lot of advice, and it's fun. Really enjoy this interview, and best luck to Data Talk Club and the Zoom camp you're going to run.
Yeah, thanks a lot. That was a pleasure to be here. Thanks.
Thank you.